Welcome back to Adventures Through Climate Change with your host, Trevor Snyder. And we are looking at another video because that's pretty much what we do for the most part. We can look at pieces of paper and stuff like that, but ultimately we'll watch videos on people talking about those pieces of paper, and then we'll critique those people, right, from our armchair, because we're doing an armchair search trying to figure out what the heck's going on with climate change, right? How much concern should we have? What type of demonization is going on right now? Beforehand, we looked at the problems with cobalt and batteries. Today, we're actually, I thought we'd take a look at how does fracking work. I have not seen this video. It's a TED ED, and this is from 5 years ago, but it has a lot of subscribers and a lot of views. So I thought it might be pretty good. It's only a 6-minute video. But basically, I spent a lot of time in the fracking industry, and I wired explosives when I worked in wireline. And when I was in the drilling process, I did casing and lay down and stuff, and then worked on the drilling rigs for a little bit. So I have a vast experience. I've done from the beginning steps to the end steps. Let's see how they break it down. When we were in the Bakken, which is North Dakota, the Bakken's the layer that it was like 30 to 90 feet of like shale and oil that, we would have to fracture, and then you'd basically pump it out. But we're drilling down 10,000, and then we're drilling over 10,000. That's a rough guesstimate, 9 to 12,000, 9 to 13,000 feet down, and then about 10,000 feet over. Let's get into it. This will give us a good understanding of what it's doing to the earth. And
deep underground lie stores of once inaccessible natural gas. This gas was likely formed over millions of years as layers of decaying organisms were exposed to intense heat and pressure under the Earth's crust. There's a technology called hydraulic fracturing, or fracking, that can extract this natural gas, potentially powering us for decades to come. So how does fracking work, and why is it a source of such heated?
So they do the same thing with the oils, and in North Dakota, we burn the gas off because it's very sulfuric, hard to filter. I think they keep some of it and use some of it, but most of it just gets burned off. I mean, it's pretty bad. But oil, I'm pretty sure they do the same way.
A fracking site can be anywhere with natural gas, from a remote desert to several hundred feet from your backyard. It starts out with a long vertical hole, known as a well bore, drilled down through layers of sediment. When the well reaches 25...
Okay, first of all, they drill down, they pull the drill bit out, they put what they call casing down there. It's like this metal stuff, and that's the aquifer. They drill through the aquifer, they put the metal casing, and then they pump down cement all the way down to the bottom, and it pushes out the sides and up around it, supposedly cementing all in the sides, and that's what that gray is around there, around the outside. And so it goes up around, so it's supposed to double insulate for the aquifer from polluting that and whatnot. So I don't know why they didn't explain that.
100 to 3,000
Then they
meters.
drill back through there.
It's at its kickoff point, where it can begin the process of horizontal drilling. It turns 90 degrees
process.
And extends horizontally for about
feet.
1.5 kilometers through a compressed black layer called the shale rock formation.
Yep.
A specialized
Shale is rock, and it's very porous, and it holds gases and oils and whatnot.
perforating gun is then lowered and fired, creating a series of small inch-long holes that burst through the well's casing into the rock layer. About 3 to 4 months after the initial drilling, the well is ready for fracking to begin. Fracking fluid is pumped down into the well at a pressure so high it cracks the shale rock, creating fractures.
Fracking, and when you explode it, so the drilling process is one thing, and they do the whole drilling process. That is done. Then they go in with the explosives. The wireline does the explosives because I had to get certified I mean, with the U.S. government, just in case I took an airplane and there was gunpowder on my shoe, I had the certificate to show that, hey, you know, I work with this stuff. But they fracture the rock, and at the very same time, they do the one stage, the very on the end, right? And then they'll go in and they'll fracture the rock right then. They won't try to fracture it the whole time. They won't perforate, and then fracture, because you won't get enough pressure in each spout to do it. So what they do is, we'll send wire line 10,000 over, so 20,000 feet down. It'll go in here, and we'll perforate this part of the pipe. We'll perforate the first part of the pipe, and then frackers will go in there and they'll pressurize like salt water and stuff, and they put so much pressure in there that it bursts through those holes and it fractures the rock up there. That's where all the gas and the oil is held. And then we'll depressurize, we'll go back in, we'll perforate a few sections, and then we'll go in and pressurize again. And we'll keep doing that all the way down. It takes, 8 hours, 10 hours, 12 hours, whatever, to perforate and frack an entire 10,000 foot span.
Through which the trapped gas and oil can escape.
Yes.
The fluid itself is more than 90% water. The rest is made up of concentrated chemical additives.
Refineries are necessary.
These vary depending on the specific characteristics of the fracking site, but usually fall into 3 categories. Acids for clearing debris and dissolving minerals, friction-reducing compounds to create a slippery form of water known as slick water, and disinfectant to prevent bacteria growth. Sand or clay is also mixed into the water to prop open the fissures so the gas and oil can keep leaking out.
I forgot to mention that sand is in that water that they pump down there. And the reason they do that is because what they just said, it fills those cracks and it allows spots for any sort of fluid to go through.
Even after the pressure is released. It's estimated that all of fracking's intense pumping and flushing uses an average of 3 to 6 million gallons of water per well.
Yep.
That's actually not a lot compared to agriculture, power plants, or even golf course maintenance, but it can have a notable impact on local water supply. And disposing of used fracking water is also an issue. Along with the trapped gas that's pumped up to the surface, millions of gallons of flowback liquid come gushing up. This liquid, containing contaminants like radioactive material, salts, heavy metals, and hydrocarbons, needs to be stored and disposed of. That's usually done in pits on site, in deep wells, or off-site at water treatment facilities.
A lot of water treatment
Another
facilities.
option is to recycle the flowback liquid, but the recycling process can actually increase levels of contamination, since the water is more toxic with each use. Wells are typically encased in steel and cement to prevent contaminants from leaking into groundwater, but any negligence or fracking-related accidents can have devastating effects.
Yeah.
Fracturing directly into underground water, hazardous underground seepage and leakage, and inadequate treatment and disposal of highly toxic wastewater can potentially contaminate drinking water around a fracking site. There's also concern about the threat of earthquakes and damaged infrastructure from pressure and wastewater injection. Links between fracking and increased seismic activity leave unresolved questions about long-term pressure imbalances that might be happening deep beneath our feet. Fracking's biggest controversy, though, is happening above the ground. The general consensus is that burning natural gas is better for the environment than burning coal, since the gas collected from fracking emits only half the carbon dioxide as coal per unit of energy. The pollution caused by the fracking itself, though, isn't negligible. Methane that leaks out during the drilling and pumping process is many times more potent than carbon dioxide as a greenhouse gas. Some scientists argue that methane eventually dissipates, so has a relatively low long-term impact.
10 years?
But a greater question hangs in the air. Does fracking take time, money, and research away from the development of cleaner, renewable energy sources? Natural gas is non-renewable, and the short-run economic interests supporting fracking may fall short in the face of global climate change. Experts are still examining fracking's overarching effects. Although modern fracking has been around since the 1940s, it's boomed in the last few decades as other sources of natural gas decrease the costs of non-renewable energies rise, and cutting-edge technologies make it so accessible. But many countries and regions have already banned fracking in response to environmental concerns. It's undeniable that fracking has reshaped the energy landscape around the world. But for what long-term benefit, and at what cost?
There is that. We don't know. And I will say, I mean, I said this before, it is kind of sad when you're out working there, although it was the most rewarding job of my life. And I would suggest manual labor, working a lot of hours and providing for your family is probably the thing that makes you a man, sets you apart in life. So with that being said, I mean, look, it's fracking. It's kind of an ugly thing. It's necessary right now. Let me know what you guys think. I hope you're subscribed. If you're not, please consider like the video if you like it. Throw down a comment, give me some suggestions, and let's adventure through climate change together. We'll catch you on the next video.